Hello PreCalc students, welcome to my garage. If you don't believe me, this is really my garage, and I'm really making this math video from my garage because I'm gone this Friday, traveling back home to Thief River Falls. So anyway, 1.4 day 2, this is average rate of change, and if you notice I put slope in parentheses because really that's what we're doing is we're figuring out the slope of a line. So real quick review of slope of a line, right? Rise over run. We could take these 2 points, we could count up and over and then build the fraction that way. Well, we're in pre-calculus, we're getting ready for calculus, so we're going to do a little better than that and we're going to use a formula for it, right? Our slope formula, y2 minus y1 over x2 minus x1. So in this case, right, this is my first point, so this is x1 and x1, y1. This is x2, y2. I'm really just plugging everything in, right? y2 is 4, so this is going to be 4 minus y1 is 1 over x2 is 3 minus x1 is negative 2. Careful with subtracting negatives. And our slope of that line is 3/5. Now, because this is pre-calc, because we're working in function notation, the slope formula that we're going to use looks a little bit different, but it's basically the same thing. So the original is y2 minus y1, x2 minus x1. What we're going to use, what you're going to see in this class, for average rate of change is this. It's kind of hard to see. That's an of right there underneath that reflection. Anyway. Instead of y2, we're going to say f of x2, meaning when we plug in x2, that's like really the y value that comes out, minus f of x1 all over x2 minus x1. And you can see it's the exact same thing, it's just in function notation instead. Okay, now the types of lines that we're going to be looking at are called, hold on, let me get to my notes. It's called a secant line. And what a secant line is, make sure we can read that, secant line. This is a line through 2 points of a curve. Kind of a plain English definition of it, but that's the idea. It's a line between 2 points on a curve. And in calculus, what you're going to use this for is estimating what the slope is at a particular point. So if we think about, we've got some sort of a parabola or something looks like this, and I want to know what the instantaneous rate of change is at this point right here. Well, in calculus, you're going to learn how to do that exactly. Before you do that, though, you're going to learn how to estimate it. And so you estimate it with a secant line by saying, I don't know how to get the slope at exactly that point, but if I choose a point maybe right here and figure out the line that goes through that point, it's probably a pretty good estimate, right? So that's really what we're building the idea of with today's stuff, with this idea of average rate of change and a secant line. All right, so first example, we're doing this function. Check where the reflections are. I can maybe write it right about here. F of x equals negative 2x squared plus 4x plus 6. And we want to know what this is on the interval from -3 to -1. Okay, now if we look at this on a graph, it's going to look something like this. We'll say that's -1, this is -3. I'm going to have a different scale on the vertical so I can fit it on here. We'll say that's -10, -20, -30. And it turns out that these points are about right here, and that curve for this upside down parabola is something like that, right? So what we're trying to do is figure out what the slope would be of a line that goes through those 2 points. So if we can imagine it'd look something like that. Now, that would probably give me a pretty good estimate of the slope between, at all the points between these two. It wouldn't be perfect, but it might be close enough for whatever it is we happen to be doing. All right, so what does that look like? We have to calculate f of x2. Now, within this interval, this one is x1, this one is x2. This is not an xy coordinate. It's got brackets around it rather than parentheses, so don't get confused there. For f of x2, we're plugging in -1 into this function. And if we plug -1 into this function, we get 0. Next, we want to do f of x1. If I plug in -3 into this function, I should get -24, okay? And that's what these points are, right? -3, -24, and -1, 0 is my, as best I could graph on a whiteboard in my garage. Anyway, now I've really got enough information that I can use that formula. It was f of x2 minus f of x1 over x2 minus x1. Subtracting with zeros, so those changed, or subtracting with negatives, so they changed to plus, and this becomes 24 over 2, which is 12. So the slope between this point and this point, that average rate of change, is 12. The slope there is 12. That's really what we just showed there. All right, there's one more example in the PowerPoint if you're following along on that. Feel free, if you got this, just move on to the homework. Be nice to the sub. I'm not going to be able to tell if you actually watched this. I'll only be able to see how many people clicked on the link. I don't have it set up to get paid on YouTube, so don't feel too bad. All right, so average rate of change, example 2. I'm not going to do a graph this time. F of x equals -3x cubed plus 2x plus 3. And we want that on the interval of -2, -1. So now maybe, if you want, pause it, try it on your own, and then come back, watch the rest of the video, and I'll show how it's done. Okay. So I want f of x2, f of x1, that's my x1, x2. So that first one is f of -1. Again, I'm just plugging in for x there, right? And that should equal 4. For this one, f of -2 for x1, and that should be 23. And now I should have enough to figure out the slope at this point, or average rate of change. F of x2 is 4 minus f of x1 is 23 over x2 -1 minus x1 is -2. That becomes a plus because you're subtracting negatives again. Be careful with that. And so this ends up being -19 over 1, which I guess we would just say is -19. So give the homework a try. Come Monday morning with questions, or Monday afternoon with questions if you're in my 5th and 6th hour. And we'll start a little bit of review then. We'll try to wrap this up and then get ready for the quiz on Tuesday.